Okay, so I'm back with the OlympicDestroyer, and as I promised, I would have a look into this thread that's created here in the main. So if we jump in here, there is some thread priority stuff that's being set here. I'm just going to ignore this for now and jump right into this discon network function. Now, the executable you can see here that I have open in Ghidra is actually the one that I annotated. So this wasn't called discon network, it just had a generic function name, and this is just the name I gave it. So now if we jump in here, you can see I already did a lot of annotations, and I am just going to do my best to explain what's going on here. So now when we look at this, there are a lot of annotations that I made. So this is actually quite readable at the moment. So first of all, I want to start off with this LPC count, which is set to all Fs in hexadecimal. Of course, if this is actually a signed number, a signed quantity, then these Fs will just be -1. Next, there is this alloc memory bytes. If you don't know what this value right here is, you can just jump over here into this assembly view and hover your cursor over it, and then you can see the decimal representation, or you can just right click and say convert here and then to decimal, and then you get the decimal value. So continuing with this wnet open enum, this gives you just a handle that you can use to enumerate network drives or network connected devices. Again, if you have a problem with these functions, or you don't know them or something like that, you can just look them up here in MSDN. For example, here's this open enum, and here you can see it starts an enumeration of network resources or existing connections. So as I said before, I always like to just comment these function definitions right here. So this gives us a handle. And down here, if everything goes well, there is this global allocation. And this allocation is done with this flag here. The decompiler actually turned the two parameters around. It's different in the MSDN, and this flag, this 40 hexadecimal, just says allocate this amount of bytes and set the bytes to 0. So set the allocated memory to 0, and then you get a pointer, which is this LP buffer. And here another pointer to this memory area is actually initialized. So now when we look at this, there are a lot of annotations that I made. So this is actually quite readable at the moment. So first of all, I want to start off with this LPC count, which is set to all Fs in hexadecimal. Of course, if this is actually a signed number, a signed quantity, then these Fs will just be -1. Next, there is this alloc memory bytes. If you don't know what this value right here is, you can just jump over here into this assembly view and hover your cursor over it, and then you can see the decimal representation, or you can just right click and say convert here and then to decimal, and then you get the decimal value. So continuing with this wnet open enum, this gives you just a handle that you can use to enumerate network drives or network connected devices. Again, if you have a problem with these functions, or you don't know them or something like that, you can just look them up here in MSDN. For example, here's this open enum, and here you can see it starts an enumeration of network resources or existing connections. So as I said before, I always like to just comment these function definitions right here. So this gives us a handle. And down here, if everything goes well, there is this global allocation. And this allocation is done with this flag. Here the decompiler actually turned the two parameters around. It's different in the MSDN. And this flag, this 40 hexadecimal, just says allocate this amount of bytes and set the bytes to 0. So set the allocated memory to 0. And then you get a pointer, which is this LP buffer. And here another pointer to this memory area is actually initialized. Alright, now continuing on, in the last video there was this kind of like scary function if you looked inside of it. I called this suspected deobfuscate because I think they're, if I look at this, some values are just decrypted or are just made unreadable, so they can't be detected by strings. I didn't look into this any more since the last video because I don't really want to reverse this, so I just left it for now. So next comes this wnet enum resource. Now here this handle that was obtained up here is used, and as you can see here, this LPC count we had before was -1 right up here, and the documentation says if the number requested is -1, the function returns as many entries as possible. So here we just want to get the network resources that are available, and then of course the malware jumps into this loop and it just goes through all of the network resources. Now this here is pretty much where the destruction happens. Here you can see this wnet add connection, and this makes a connection to a network resource. So what this here does is it goes through all of the resources that were obtained, so through every network resource that it can get to, and then if a connection is made, this walk files is called. Now again, I just annotated this, so this wasn't called walk files before, and also this wasn't called net resource name. So just remember that in case you want to retrace my steps or reverse this yourself, these are all annotations. So now if I just jump in here in this walk files, this is actually, as you can see, a lot of code that's in here. So again, I will go through this step by step. Up here, a buffer is written with the resource name of this network resource, and then the wildcard, this asterisk here. So then the find first file function is called. Now this find first file, and as you can see down here, this find next file is actually used or can be used to traverse files in a directory. And this also comes up in ransomware, at least in some ransomware that I reversed. This was also programmed in there. So I think this is something that is, well, I'd say common, and just maybe something to look out for. Now, this find first file, it obtains a file handle, and again, here's the check. If a handle was obtained, then the malware goes into this big loop. Now, the information about the first file that was found is actually stored here in this find file data. This is again a function that you can look up on the MSDN if you don't know what it does or if you are uncertain about some parameters. So let's jump into the loop. Now here, a handle to the heap is obtained, and then memory is allocated. You can see here it has 1040 bytes, and this flags 8 is just to say initialized to 0. So the allocated memory is initialized to 0. Now you can see this net resource name, which is actually just a pointer to this net resource name that was passed in as a parameter to the function, is appended here, and then also this local variable. Now I didn't find out what this is because it's referenced here for the first time, but I just suspect that this is something that maybe is changed somewhere up here. Now the more interesting part is actually this here. Here you can see this find file data and this ends with 16. Now if you look this up, then you find out that 16 is actually file attribute directory. So this will then just check, is it not a directory? If it is a directory that we got, this walk files is called again recursively. So in here, this is actually what is executed when a file is found. This create file function is used to open the file. A handle is obtained and also the file size down here. Next, the handle is closed. Now don't be confused by this handle heap. It's just the same value used twice. Once up here for this handle to the heap, and then down here again as a handle to this file. Now create file is also, or maybe a little bit confusing. If a file already exists, create file opens the file, and if it doesn't exist, it's created. So this just opens the file that is stored in this alloc memory. The file size is then obtained and the handle is closed. Now here you can see there are two possible ways this program can go. If the file size is below this value, this wipe file is called. Again, I annotated this so it's not called wipe file normally, and otherwise if it's larger than this value, this wipe large file or file large is called. So this wipe file large is actually a little bit easier to read than this wipe file, so I'm going to go here first. So now again the file name is passed as a parameter, and the create file function is used to open the file. Then down here the file pointer is set with this -1. So this actually goes backwards in the file. Now here this unknown buffer, which you can find up here, which is not initialized or anything, is just written to this file. So right here, this just shows us that a file handle is obtained and just some random values are written to the file. And this is actually destroying the file. Now for create file, there is this parameter right here. And this is just the value behind generic write. So there's a macro in the Windows 32 API that's called generic write, and this is the value behind it. So this create file opens the file in write mode. That's what you can see here. So if it's not writable, the function will return and not write anything. But the thing to remember here, or the main thing that happens here, is that this unknown buffer, these random values are written to the file. So this is actually just overriding parts of the file. Now for smaller files, I jumped ahead to this wipe file function, and I did a little bit of annotation here too. So here's this the obfuscate again that I didn't look into, and an unknown buffer again. So here you can see generic write is this value here. So the file is opened in write mode. If this was successful, we just come down here, and this is quite a big block of data. And I will just summarize what happens here. Again, this set file pointer with -1 is used to go backwards in the file, and then exactly 1 byte is written. As you can see here, this third parameter is the number of bytes to write. Now, down here, this gets file size is called to get the file size, and the file pointer is set here with the 0. And then, if we just go down here again, we can see that this write file is used to write this unknown buffer with this number of bytes to write, which is calculated here using this file size. This write file just writes this unknown buffer to the file. So again, this unknown buffer we can find up here, and I couldn't find anything that allocates this or sets some values, so I'm just going to assume it writes unknown values to the file. So now I jumped back to this Discord network that I annotated, and once this walk files is done, the network connection is cancelled and the next network resource is obtained. So here, in summary, we can say that this thread that is created just steps through every network device, or as it says here, network resource or existing connection, takes every file that it can find that is writable and writes these garbage values to it. And after that, it just cancels this connection that was initiated here. So here you can see that this malware is really after destruction. It goes through the whole network drives or network resources that it can find, that it can obtain, that it can connect to, and just wipes the files. So with this, I think I'm now through explaining what this does. And because in the last video we already talked about everything that happens before this thread, I think this concludes my little analysis of the wiper component of the OlympicDestroyer malware. So thanks for watching this video, and I will see you around.